Good day there guys, welcome to your tutorial. In this video we're going to be looking at Angular signals. So we already have a working Angular app. It filters correctly, it resets correctly, and it defaults correctly, right? There's no visible bugs. So why are we even changing anything in this tutorial? And the thing is, it's not really about fixing behavior. It's more about improving how we model state. So the end result is going to be the same UI, the same behavior, just with better architecture. And let's have a look at what we're starting with, right? So we have a gym class browser. We have different tier levels. We have a basic, a pro, and elite. We have available classes, and these available classes are filtered by the tier. And we have a selected class over here. So at the moment, this is getting defaulted to the first available class, right? If we go ahead and go to the elite, we can see that we have two additional classes. And once I actually select the heat, we know that the basic doesn't have the heat option. So once we click the basic, we can see that it actually resets correctly and defaults back to the first available class, right? So from a user perspective, everything looks fine, right? So let's have a look at the code. So we have two plain properties over here. We have a tier and we have a selected class ID. Then we have derived getters, we have the filtered classes, and we have the selected class, right? Then we have in the set tier, we have manual logic basically to keep everything in sync, right? So if the tier changes, we then check if the selected class is still valid. If it's not, we reset it. So that works. I mean, it works, but I mean, we mainly enforcing relationships between pieces of state, right? And let's just zoom out for a bit. So Angular runs change detection when something happens. Angular doesn't understand your state relationships. It doesn't know that the filtered classes actually depend on the tier, right? The consistency is still your job, and that's why we wrote this reset logic manually. And signals exist to fix that exact problem, right? So let's before we refactor, let's actually just define them properly, right? So what is a signal? Like, to put it simply, it's just a piece of state that Angular keeps an eye on, right? A state that Angular tracks. So if I write this plain property over here, public tier, equal to basic, like Angular doesn't know who reads that value. But if I write public, and I'm just going to comment this out, but if I write public tier equal to signal basic, now Angular tracks it. And when something reads it, which is like over here, Angular remembers, this depends on tier. So that later when I actually go ahead and set it, which is over here, later when I go set it, Angular automatically updates anything that depends on it. And that's the entire idea. Signals let Angular understand what depends on what, instead of us mainly managing that relationship. And I kind of gave a sneak peek into how to use the signal, and I'm just going to go through the 4 tools that we're actually going to be using in this tutorial. So as we went through the first one now, which is just a signal, this is a writable signal. It's basically a writable piece of tracked state. So you read it as I've shown. You read it with these parentheses, so almost as if you're calling a function, and you update it with a dot set, right? And that's your base state. Then we have computed. So a computed signal is a value derived from signals, right? So that being said, right, it's read only. So it's not like a writable signal where you can do a dot set and those type of things. It's read only. It's just the value derived from other signals, and it automatically reruns when its dependencies changes, right? Or when its dependencies change. You can think of it as like a reactive getter, right? Then the next thing we're also going to be looking at is an effect. An effect is a function that runs when signals it reads change, right? So inside the effect, we might read a signal, and then when that signal changes, that's when the function will run. And in our case, in this tutorial, we're going to do a snack bar just with the selected class, right? So that effect is just for side effects, and it reacts automatically. Then the next thing we're going to look at is a link signal. Now this one is important because it's going to be the way that we clean up this manual reset logic. All right. So just in terms of let's just try and put a little bit of a definition to this thing, right? So link signal, it's a normal writable signal, right? This is a normal writable signal, so you can still do a dot set and those type of things on it, right? But it also has a reactive default value, right? So let's just think about this for a second. So it behaves like a regular signal. You can call dot set on it, but its starting value depends on other signals. And when those signals change, Angular recalculates the default if needed. So in our case, right? In our case here, we want a selected class, right? That defaults to the first available class. So you want to select a class, and then that defaults to the first available class, and automatically stays valid when the filtered list changes, right? So we want a selected class, right? We do want this. We want it to default to the first available class and automatically stay valid, which is this piece here, when the filtered list changes. But, and this is the key thing also, it's also still manually selectable by the user. So in our case, when you do a pick class, you can see we still do a set on it, right? And that's exactly what the link signal is for. It's a writable signal that stays in sync with another signal. It's just maybe a bit of a simpler way to think about it. So let's maybe just start our refactor, and then as we go along, you'll see how things change. So we've kind of already started that while I was defining the signals. So we have changed the tier to be a signal. We've changed the way the tier actually gets read, and I actually just want to put this in a variable. So I'm just going to call that tier there, and then also we've updated already the tier in terms of setting. The next part we have to update is on our mockup. So let's just call this as well, because remember it's a signal, so that's the way that we would read the signal value. Then let's go ahead and just convert our all classes. All classes, like I said, all classes right now, it is static. However, this will come from potentially a service, or this is going to be from wherever, basically, in your application. In our case, it is static. However, I'm just going to make this a signal as well, and that's just kind of future proofing, because in this application it is static, but in the real world this may not be. So I'm just going to go ahead and do this. So this will still be a signal. We have all tiers, we have all tiers, we have all classes. All tiers, I'm not going to convert that to a signal. We're not actually going to use that in any of our signals that we are going to be defining. But the all classes one is, so therefore I just made that one a signal. I'm just going to update the way that this is being read. So remember the round brackets. Just going to go ahead and save that. Alright, then I'm going to look at the filtered classes. So let's go ahead and convert the filtered classes to a computed signal, right? So filtered classes, what is filtered classes? Filtered classes is all classes filtered by that tier allowed property based on your current tier, right? So I'm just going to go ahead and comment that, and I'm going to go ahead and do let's just copy this name. So exact same name. I'm just going to go ahead and do computed, and then let's just open these up. There we go. So I'm just actually going to copy this, paste, and then I'm going to uncomment. So let me just go ahead and delete this. We don't need this anymore. So in this case, tier, the start tier, which is the signal. Then we're going to still use the all classes and still keep the same kind of folding. But what we basically did here, we converted the getter to the computer, right? But what we basically did here was we allowed this to be reevaluated when either the tier changes or the all classes have changed. That's kind of the reactivity that we get. And as I said, this filtered classes is now a signal. So when we do use filtered classes, we will have to update how that is being used, right? and I am updating this just so that it does compile. However, you will see that this code for filter classes is not actually necessary once we do the conversion to a linked signal. Alright, so let's just update this over there. Alright, so now the next thing that we can do is look at the link signal, and that's going to be on the selected class. So as I said, filter classes, that's done. Filter classes now automatically updates when a tier changes, right? And as I said, in our case, all classes won't change, but we have set it up in case in case all classes are able to change. All right. So the next thing I want to do is I want to do some cleanup on this default defaulting that we're doing for the selected class ID, and also this manual reset logic. That's basically what I want to clean up, and I want to use this selected class ID for that. So what I want to do is I'm going to convert this to a linked signal, right? And how this looks is so if you look at the constructor, right, we basically said, hey, set the selected class ID to this here, which is the first element in the filtered classes array, right? So now we have converted filtered classes to a signal. Now this is a signal. So now what I'm gonna do is I'm gonna take this and put it inside my link signal. So now whenever filtered classes change, this will be reevaluated, and this selection will be valid. So we don't need this anymore because we've added that in. And also the bonus of this is we don't need this code anymore. What? Wait, what? So now we have selected class ID simply set to a link signal using the filtered classes signal and just defaulting to the first element there. Wait, what? So okay. So just to explain this signal defaults to the first filtered class, right? When filtered classes changes, Angular reevaluates this default. If the current selection is no longer valid, it resets automatically. And we didn't write any reset logic. So we don't need a constructed default. We don't need that validity checks. That consistency is automatic. So, and I'm going to show you once we update this correctly, I'll show you how this works exactly the same as it did before. So I'm just going to update this because this is now a signal. We have to update the way that the value is read, and as I said before, is a link signal, so we are still able to do a dot set. There we go. And we need to update our markup. Let's just save that. Alright, so I'm just going to go ahead and clean this up. We have our tier, that's a signal. We have our selected class ID, that's a signal. We have our filtered classes, that's a signal. We still need to update our selected class, so let's go ahead and do that. So our selected class, which will just be selected class equal to, and this is also going to be a computed signal. And I'm just going to take this logic over here and paste that. That has already been updated correctly, so this is already a signal, this is already a signal. And remember, with computed signals, it's derived, so it's derived state. So when selected class ID changes, this will be reevaluated. When all classes changes, this will be reevaluated, because these are two signals that it reads, right? And just to show you, this is read only, so I will not be able to do a selected class dot set. All right, so let's just go ahead and save that, and then in the markup, let's just go ahead and update the way that value is read. I'm going to go ahead and save that. All right, so we can see that things are looking a little bit leaner, a little bit cleaner. But let's just make sure that our application is working correctly. So we have our tiers, we have available classes, we still have our default selection, so we didn't lose that. Let's just make sure that this reset and that behavior is working correctly, because we took out that code. We changed it to a link signal, and I told you it's automatic. So let's see. So if we go to elite, we can see that still the default selection is correct. We select the 8 o'clock one, we go back to basic, we can see that it did actually kick us out, and it did do a default selection to the first available class. So that's basically the power we get with this. And just to show you the last piece that I was mentioning, which is the effect, I'm going to go ahead and add an effect. So I'm going to say, just going to do this in the constructor. I'm just going to do an effect. Like I said, this is just a function. However, any signal that's inside of here will cause this to we'll call this to run. So I'm just going to do, let's just say selected class, this dot selected class, and so whenever selected class actually gets changed, then this will cause this effect to run. So let's just say if let's just actually call the snack bar. So let's set that up. So I do not have the snack bar here, so I'm just going to say private read only snack bar. And in this tutorial, we are using Angular material. Just as a note, I'm just going to say this dot snack bar dot open, and we're going to keep this very basic. We're just going to say selected. Let's just say selected class dot, let's just use the name, and then we do know that it does have a value, and then let's just say let's just keep it simple as that. Selected that, and then next one, there's no action for this, and then in terms of config, let's just let this show for let's say one second. All right, so let's just save this. So again, it's an effect. Signals that are inside of it will cause it to rerun. So when selected class changes, that's when this will execute. So if we go over here, let's just go to elite, let's change it to heat. You can see that we have now a little snack bar. We go basic, and you can see it changed it because it had to reevaluate that default. If you go to pro, select spin, selected spin. So yeah, that's pretty much all for this tutorial. So before, we were doing manual syncing, we were doing imperative resets, we were doing hidden state relationships. After, our base state is now explicit, our derived state is now explicit, our relationships are declared, and Angular maintains that consistency automatically. So signals aren't magic, they just give Angular visibility into your state graph. So instead of like, if this changes, fix that, we say this depends on that, and Angular handles the rest. So it's the same behavior, cleaner thinking, and just less mental overhead. And I really hope you enjoyed this video. Please give this video a like, and please subscribe to the channel. Thank you.